Hello everyone, welcome to grade 10 mathematics, and we are now on our first quarter, week number 3 and 4. So this is for 2 weeks, and the most essential learning competencies are competencies number 4, 5, 6, and my name is Flora Lauta, and I will be your mathematics teacher for today. Before we start, please prepare again the following: your grade 10 modules, your paper, and your ball pens. So for class rules and objectives, our objectives for today is to illustrate a geometric sequence, differentiate a geometric sequence from an arithmetic sequence, and determine geometric means and nth term of a geometric sequence. And of course, make sure to focus on the lesson, and as always, do not open your social media apps while the lesson is ongoing to avoid distractions, and of course, solve along with your teacher. Our lesson for today is about geometric sequence. So please open your modules on page 11. And the concepts and keywords that we are going to deal with today are geometric sequence, common ratio, geometric means, nth term of geometric sequence. What is geometric sequence? Geometric sequence is also called geometric progression. It is a sequence where each term after the first is obtained by multiplying the preceding term by the same constant. So for example, we have 6, 12, 24, 48. As you noticed, we are multiplying each term by 2. So we have 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. So therefore, that same constant that we are multiplying to each term is 2. Or 1, another example, 1, 2, 4, 8. So we are also multiplying each term by 2. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, and so on. So these examples are called geometric sequence. Okay, so let us see if you are able to identify the difference between arithmetic or geometric sequence. Number 1, negative 10, negative 50, negative 250. So is this arithmetic or geometric? Okay, so this one is a geometric sequence. As you noticed, we are multiplying each term by 5. So negative 10 times 5, negative 50 times 5, negative 250. Number 2, 24, 12, and 6. Is that arithmetic or geometric? Okay, so this one is also a geometric sequence. We are multiplying these terms by 1/2. So 24 times 1/2 is 12, times 1/2 is 6, and so on. And then number 3, 8, 16, and 32. So that's easy. This is geometric sequence. So we are multiplying by 2. So 8 times 2, 16, times 2 is 32. Number 4, 24, 12, 0, and negative 12. Okay, so this is arithmetic sequence. So as you noticed, we are subtracting 12 or adding negative 12. So 24 minus 12 is 12, minus 12 is 0, 0 minus 12 is negative 12. So this one is our, remember, from arithmetic sequence, we have our common difference. Okay, next, number 5, negative 4, negative 17 fourths, negative 9 fourths, negative 19 fourths. Is that arithmetic or geometric sequence? Okay, so this is also an arithmetic sequence, and the common difference is negative 1/4. Or okay, so if you can remember, in arithmetic sequence, there was a formula that we are following. So the formula was a sub n is equal to a sub 1 plus n minus 1 times d, where d is the common difference. So this is for arithmetic. And for geometric sequence, we are also following a formula, which is a sub n is equal to a sub 1, the first term, times r to the power of n minus 1. So again, a sub n is the nth term in the sequence, or the last term. A sub 1 is the first term in the sequence. And the r is the common ratio between terms. So r is that fixed number that you multiply to each term of the sequence. Common ratio is a constant multiplied to each term of a geometric sequence to obtain the next term of the sequence. And we follow this formula to find the common ratio. We have r is equal to a sub 2 divided by a sub 1 is equal to a sub 3 divided by a sub 2, or a sub n divided by a sub n minus 1. Okay, so let's take these examples. We have example number 1, 6, 12, 24, 48. So by looking at it, we know already that the common ratio is 2 because we are multiplying each term of the sequence by 2. But let us just show how to find the common ratio using the formula. So we have r is equal to a sub 2 divided by a sub 1. So a sub 2 here is 12, and then a sub 1 is 6. So 12 divided by 6 is 2. So therefore, our common ratio is 2. So as you can see, 6 times 2 is 12, 12 times 2 is 24, 24 times 2 is 48. Now let's have example number 2, 5, 2, 4/5, and 8/25. So r, again, is equal to a sub 2 over a sub 1, which is equal to a sub 2 is 2 and a sub 1 is 5. So we don't need to simplify that. Therefore, our common ratio is 2/5. So as you can see, 5 times 2/5 is equal to 2. 2 times 2/5 is equal to 4/5. 4/5 times 2/5 is equal to 8/25. Okay, next. So let's try to solve this example. What is the 12th term of the geometric sequence 4, 4, 2, 1, 0.5, 0.25? So before we solve for the 12th term, let us try to find the common ratio first. So remember the common ratio is equal to a sub 2 a sub 2 divided by a sub 1. So a sub 2, our a sub 2 is the second term, which is 2 over 4, which is also equal to 1/2. So our common ratio is 1/2. Now let's try to solve for the 12th term. To solve for the 12th term, we know that we are looking for a sub 12. And then using the formula, we have a sub 12 is equal to a sub 1 times r, the common ratio, times n minus 1. So a sub 12 is equal to a sub 1 times the common ratio time to the power of 12 minus 1 is 12 minus 1. Okay. And then a sub 12 is equal to a sub 1 times r to the power of 11. Now, we know that a sub 1 is 4. So, we have a sub 12 is equal to 4. And then our r is 1/2 times 1/2 to the power of 11. Now, we have a sub 12 is equal to 4 times 1 to the power of 11 is 1 over 2 to the power of 11. So, a sub 12 is equal to 4 and then 1 over 2 to the power of 11 is 2048. So, that will be 4 over 2048. And the final answer is 1 over 512. Or since the given is in decimal, so we change our answer, final answer to decimal, which is 0.001953. So the a sub 12 or the 12th term of the geometric sequence is 0.001953. Let's try to solve example number 2. What is the 15th term of the geometric sequence 1/2, 1/3, 2/9, and 4/27? So remember, our formula for a geometric sequence is a sub n equals a sub 1 times r to the power of n minus 1. Now, let's solve first our r, or the common ratio. That will be a sub 2 divided by a sub 1. And our a sub 2 is 1/3 divided by our a sub 1, which is 1/2. And that will be 1/3 times the reciprocal of our denominator, which is 2 over 1. And the final answer is 2/3. So that is our common ratio. Now, we need to find the 15th term. So that will be a sub 15. Okay, because we're looking for 15th term, which is our n. So a sub 15 is equal to a sub 1. And our a sub 1 is 1/2. And our r is 2/3 to the power of n minus 1. So our n is 15 minus 1. So that is 1/2 times 2/3 to the power of 15 minus 1 becomes 14. So 1/2. So 2 to the power of 14 is 16,384 over 3 to the power of 14 is 4,782,969, and multiplied by 1/2, the final answer is 8,192 over 4,782,969. So this is our a sub 15, and this is our final answer. So looking that, or going back to the question, what is the 15th term of the geometric sequence? The 15th term of this sequence is 8,192 over 4,782,969. Geometric means? So if you can remember, with arithmetic sequence, we also had arithmetic means. So for geometric means, it's just the same. Those are numbers in between two non-consecutive numbers of a geometric sequence, so just like arithmetic means. So for example, we have geometric sequence 4, -2, -1, and -1/2. Numbers -2 and -1 are the geometric means of 4 and -1/2. And also with 1, 2, 4, 8, the numbers 2 and 4 are the geometric means of 1 and 8. Example 1 for geometric means, we have find 3 geometric means between 2 and 32. So here, let us list the terms for the sequence. We have 2, and then we need 3 geometric means, 1, 2, 3, and then 32. So we have a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. So it's just the same with arithmetic means, only that for geometric means, we are going to use the geometric sequence formula, which is a sub n is equal to a sub 1 times r to the power of n minus 1. And we know that the given are a sub 1, the first term, and the last term, a sub 5. So our last term is a sub 5 equals a sub 1, and then r is unknown, and n now is 5 minus 1. And a sub 5 is 32, a sub 1 is 2, and r to the power of 5 minus 1 is 4. So 32 and is equal to 2r to the 4th. Okay, now we have to get rid of 2 here because we only need r, right? So divide both sides by 2. Yan. So 32 divided by 2 is 16 equals, so wala na tong 2. We have r to the power of 4, or r to the power of 4 equals 16. Tapos, 4th root of r. So, kung anong ginawa sa kabila, yun din yung gawin dito sa kabila para mawala yung root niya. We have r is equal to 4th root of 16. And 4th root of 16 is equal to 2. So, our r, or the common ratio, is 2. Since we know the common ratio, we know now what number we need to multiply to the first term to get the next term. So that will be 2. Ito. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So therefore, the geometric means, the 3 geometric means between 2 and 32 are 4, 8, and 16. Okay, example number 2 for geometric means. Find 4 geometric means between 1/4 and 256. So again, we have 1/4, and then we need 4. 1, 2, 3, 4, and 256. So we have the given a sub 1, and we're looking for a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6 is our last term. So using the formula, we have the last term as a sub 6 equals our first term is a sub 1, r, and our n is 6 minus 1. So we have a sub 6 is equal to a sub 1 r to the power of 5. And our a sub 6 is 256 equals our a sub 1 is 1/4 r to the power of 5. So we have now 256 equals 1/4 times r to the power of 5. Multiply both sides by 4 because this one is 1/4. So multiply both sides by 4. So 4 times 256 is 1024 equals we cancel this out, then we have r to the 5th. So let's get the 5th root. Now we have r is equal to the 5th root of 1024, and the 5th root of 1024 is 4. Okay, now we know that our r, or the common ratio, is 4, so multiply all the terms to 4. So 1/4 times 4 is 1. 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4 is 256. Now, our geometric means are 4. Therefore, our geometric means are 1, 4, and 16. Are the geometric means of 1/4 and 256. Okay. Okay, so let's have another example here. This example involves a variable y. So let's try if we can solve this. So find y given the geometric mean between 2 and y is 10. So what does it mean? So sabi dito, yung geometric mean between 2 and y daw is 10. So therefore, we have 2 and then y, and then their geometric mean is 10. So it's very easy. Our sequence is 2, 10, and then y. All we have to do is to find out what is y. And as you notice, since this is a geometric mean, as you notice, we just multiplied it by 5, using the formula for r, we have 10 divided by 2, or a sub 1 divided by a sub 2 divided by a sub 1, which is 5. So 2 times 5 is 10, and then 10 times 5, we have 50. So therefore, y is 50. So the final geometric sequence here is 2, 10, and 50. Or if you want to use the formula, a sub n is equal to a sub 1 r to the power of n minus 1. We know that our last term is y, so that is our a sub n, and then our a sub 1 is 2, and then our r, we know our r is 5, so times 5, and our n is 3 because this is 1, 2, 3, so y is the third number, so 3 minus 1. So y is equal to 2 times 5 to the power of 3 minus 1 is 2. So y is equal to 2 times 5 squared is 25. Therefore, y is equal to 50. So it's the same answer. Okay? Okay, so just to recap, today you were able to learn about the geometric sequence and the common ratio and its geometric means, and of course you were able to find the nth term of a geometric sequence using the formula a sub n is equal to a sub 1 times r, the common ratio, to the power of n minus 1. Okay, so that's it for today. And now it's activity time. So please answer the activity sheets or the worksheets that your teachers will give you. And of course, before I let you go, I want to leave you this message that hardships often prepare ordinary people for an extraordinary destiny. And this is by C.S. Lewis. So kahit nahihirapan man tayo ngayon, kayang-kaya natin yan dahil sa future, magiging okay din ang lahat. And of course, hindi lang okay, kundi extraordinary. Okay, so again, thank you so much for attending the lesson and see you again next time. And please don't forget to subscribe and hit the like button and the notification bell for more lessons in the next week and the next quarters. Thank you so much, and this is your teacher Flora. Have a great day. Goodbye.